Good evening, everyone. Myself, Sindhani Misri from CSC third year, and as a part of my machine learning and techniques laboratory. Now let us look into experiment number 6, where the aim of the experiment is to implement a hierarchical agglomerative cluster. So first looking into this, in this experiment we will implement an hierarchical agglomerative clustering, which is a bottom-up clustering approach. Unlike K-means or SOM, it does not require initial centroids. Instead, it builds a centroid, a hierarchy of clusters using a distance-based merging. We will evaluate the model and visualize the results in Tableau. Now first we are going to import the necessary libraries for handling visualization, clustering, and evaluation, which are pandas, numpy, matplotlib. And for pre-processing, we will use standard scaler for standardization. As for the clusters, we will take agglomerative cluster from sklearn. And for metrics, we will take Silhouette score, Davis-Burdon score. And then next, we are going to take linkage and dendrogram to visualize the graphs accordingly. So first, we are going to import the dataset, which is customer cluster.csv, and then we are going to print the first 5 rows of the dataset. Next, we are going to standardize the data. Since the clustering is a distance-based feature, it must be scaled, otherwise the features with large scales will dominate the clustering. So first, after importing the dataset, here we are going to take the data types which only includes numerics, which are nothing but integer and float. And we are going to standardize using standard scaler and going to fit the data into the model. And then after the standardization, we would get the output as the given here. Next, we are going to apply linkage and plot the dendrogram. Hierarchical clustering builds a tree-like structures called dendrograms. It shows how clusters are made step by step. So as a part of it, first we are going to take the numerics again, and using linkage function we are going to link the features which are xscale. Xscale is nothing but the x which we have been standardized before, and then using method single, using metric calculation of Euclidean, which measures the distance between two points in the data, and then we are going to plot the dendrogram. So this should be the plot we get. Here we can say the approach is from top to bottom approach, bottom to top approach. So next we are going to, so by observing the dendrogram, we can decide that optimal number of clusters by cutting the tree at certain height can be figured. Next, for the fourth question, we are going to create the cluster models. So cluster models, here we create multiple models with different clusters, which are numbers which we compare from the performance. So first, we are going to use the standard scaler for standardizing the data again. And then here we are using two models. We have named two variables, model 1 2 and model 1 3. So agglomerative clustering for the two clusters and for the three clusters. The metric would be Euclidean and the linkage. So after this, we have created the model successfully, and now we are going to fit the model and predict the cluster labels. So once after we have done with the model initialization, we are going to fit the models using labels 2 and labels 3. Here we are going to fit the models using fit predict function. So once after the model is fit into it, now we are going to print it. So here we can see for two labels, the approach would be this, and for the three labels, it would be this. So we can see there is difference between the two clusters which we have declared. So once after we have done with predicting and fitting the model, we are going to visualize using the scatter plot. So here for the scatter plot, we are going to take the variables data milk and data grocery as x and y axis, and then labels which we have predicted from the above. And then using rainbow function, we are going to differentiate with the different clusters. So red, green, and blue, which varies the different types of clusters. So scatter plot helps us visualize how clusters are separated using two features. So once after this scatter plot is plotted, next we are going to evaluate the clustering performance. So For the clustering performance, we use three metrics. One is silhouette score, other one is Boldian index, and the next one is uh, mutual information. Whereas silhouette score measures how well clusters separated, and the higher the silhouette score, it predicts it means it is a best model. And for the David's Boldian index, it measures how cluster is similar to each other. When it is lower, it means the model is best model. For the mutual information, it is a measurement which is the agreement between the clustering results. So for taking between the label 2 and label 3, which is nothing but two clusters and three clusters, we can see it has very slight difference in the silhouette score, and it varies a lot coming for the David Boldian index and mutual information. So the one with the more silhouette score and less Davian Boldian index and with lesser mutual information gives us the best model. So next thing we are going to select the best model. So for that we are going to take all the scale models and then labels to predict it. So if for the score 2 we are going to take the silhouette score, and for from the labels by fitting the model and by initializing the model into it, we would get some variables such as score 2 and score 3, and we are passing this into this silhouette score. So if score 2 is greater than score 3, we would print the cluster 2 is the best model. So if it is the other case, then cluster 3 will be the best model. So best model is printed here where it is two clusters, which is nothing but label 2. Next, we are going to visualize the data in the tablet. So for that, first we are going to import the all the results which have come from this model training and fitting the model into agglomerative clustering into a data set called customer clustering results. And once after we run this, this is the output we get. There is a values change in the values after handling all the missing values and pre-processing and standardization of the data, and after fitting the model into standard in agglomerative clustering, you would get the data set. Thank you.